Good morning, students. Welcome to the class of Technomathematics. Today we'll solve a numerical where three masses m, 2m and 3m are suspended over two pulleys, which I have marked over here as A and B, and the arrangement of the suspension is shown as in figure, right? So let us assume the acceleration of the two portions to the left of and right of pulley B is A2, and similarly acceleration on the left and right of pulley A as per the suspension is A1, right? Now let the tension in the two suspensions of pulley B as T2 and T1 as the tension in the two strings as suspended through the left and right of pulley A, right? Now, we know that due to acceleration due to gravity, the weight, the downward force acting on M, 2M and 3M as mg, 2mg and 3mg, right? Now, if you consider pulley A, right, the total forces acting on it is, if you consider the free body diagram of pulley A, then 2T1 acting downward will be equal to 2 will be equal to T2 acting upward, right? So, we had written T2 equal to 2T1, right? This is one of the relation which is coming as per the free body diagram of pulley number A, right? Now come to the second body, that is the mass M. For mass M, what are the forces acting on it? Let us calculate. T1 minus mg is the equivalent force acting, right, upward, which will be equal to the m into a1 plus a2. The acceleration of the mass m will be a1 plus a2, because you can see the direction of a1 and a2 is same, right? Now similarly, the for mass 2m, what will be the free body diagram and what are the total equivalent forces acting on it? It will be 2mg minus t1 is equal to a1 minus a2 into 2m. In the RHS, F equal to m into a, where the equivalent acceleration of the 2m mass is a1 minus a2, because you can see the direction of a1 and a2 is different, right? Similarly, if you consider the mass 3m, then what will be the equivalent forces acting on it? It will be 3mg acting downward minus T2 which is acting upward is equal to ma. That is 3m is the mass into a. Acceleration of the 3m mass is a2, right? So this is the fourth relation we have achieved, right? This is the fourth relation we have achieved. Now we just number the equations which we have derived. Now let us assume the first equation, second equation, third equation and fourth equation as we have derived it, right? These are the four equations. Now do one thing, add both the equation, that is equation number 2 and 3. When you add both the equations 2 and 3, what we will get, you can see, we will come up with a relation. Let us just add the LHS with the LHS of equation number 2 and 3 into the LHS of the resultant equation, and RHS of the equation number 2 and 3 into the resultant equation RHS, right? So here in the LHS you can see T1 is cancelled out, and in the LHS we are left with m into g, right? And in the RHS we are having 3a1 minus a2 into m. Here you can see m is also common into the LHS and RHS, right? So we come up with a relation that g is equal to 3a1 minus a2, right? This is also one of the important equation as we derived over here, right? Now do one thing, subtract the same equations again, that is subtract equation number 3 from equation number 2. Then what we will get, just subtract the LHS of 3 from the just from 2, that is LHS of equation number 2, and RHS of equation number 3 from the RHS of equation number 2, right? So in the LHS we are having T1 minus mg minus 2mg plus T1, right? and into the RHS we are having A1m plus A2m minus 2A1m plus 2A2m. So just solve it. So we come up with a equation 2T1 minus 3mg equal to 3 times A2m minus A1m, right? And 2T1 minus 3mg equal to m, take m common into the RHS, and 3A2 minus A1, right? Now this is an important relation which we have derived. Now coming up to the relation from equation number 4, that is 3mg minus T2 equal to 3m into A2, right, which is coming as per the free body diagram of mass 3m, right. Here into the LHS you can see T2, and from equation number 1 we are having T2 as 2T1, right. So put up the value of T2 as 2 times T1, that is from equation number 1. Now when you put up the value, what we will have? We will have, since T2 equal to 2 times T1, so we will have into the LHS of equation number 4 as 3mg minus 2 times T1 is equal to 3ma2, right. Now what we will be having, just mark it. Now this is an important relation which we have derived, that is 3mg minus 2 times T1 equal to 3ma2, right. Just number of the equations 5, 6 as shown over here, right, and add both the equations 5 and 6 which we have derived just above, right. When we add the equation number 5 and equation number 6, that is LHS of equation 5 to LHS of equation 6 and RHS of equation 5 with the RHS of equation 6, we are having 2T1 minus 3mg plus 3mg minus 2 times T1 is equal to 3ma2 minus ma1 plus 3ma2, right. Here 2T1 is cancelled out into the LHS, and 3mg is also cancelled out into the LHS. So into the LHS we have 0, and into the RHS we have 6ma2 minus ma1. Just bring minus ma1 from RHS to the LHS and cancel the m component in the LHS and RHS. So we will be having we will just derive the equation a1 is equal to 6 times a2, that is acceleration of one of the pulley is equal to 6 times the acceleration across another pulley, that is a1 equal to 6 times a2, right. Now we have already derived equation above. In one of the equation above, though we have not numbered it, let us number it, that this is the equation number 7, that is z equal to 3a1 minus a2. Just mark it as equation number 7. Now we are writing, just rewrite this equation over here below, z equal to 3a1 minus a2, that is by equation number 7, g equal to 3a1 minus a2, right. And as we have derived just that a1 is equal to 6 times a2, so put up the value of this a1 as 6a2 into the equation number 7. So we will having, so that we will be having only one variable, that is a2, and we have assumed the a2 as the acceleration of the mass 3m, which we have to find out as per the question, as per the shown numerical, right. So just solve it to get g equal to 17 times a2. So we can write a2 equal to g by 17, that is acceleration due to gravity is g, a small g divided by 17, right. So a2 equal to g by 17 meter per second square is the acceleration due to acceleration of that mass due to due to the position as shown hanging across the pulley, right, through one end of the pulley B, right. So the acceleration of the mass 3m is z by 17 meter per second square. So this question is solved. Happy learning, keep on learning. Bye bye, take care and subscribe to my channel and enjoy. Bye.